All right, let's get right into it. Today we're tackling the BPSC Sub-Engineer Civil Exam. We're going to break down all 10 of those core subjects and hand you a real, actionable blueprint for success.
So you're looking at 10 subjects for one exam. Yeah, it's a lot. It's totally normal to feel a bit overwhelmed, like you're staring up at a huge mountain. But hey, don't sweat it. Think of this explainer as your map. We're going to climb that mountain together, one step at a time.
Okay, so here's the game plan. We'll quickly look at the challenge, then I'll give you a winning strategy. After that, we'll blast through 8 subjects in a lightning round. Then, we'll slow down for a deep dive into surveying and mechanics, and finally, wrap it all up. Sound good? Let's do it.
You know, the toughest part for most people isn't how hard the questions are, it's just the sheer size of the syllabus, right? Getting a handle on that huge scope is absolutely the first, most critical step. So, how do we actually tackle it? Well, it's not just about putting in the long hours. It's about working smart. So let's break down a simple, proven 4-step strategy that's going to be the foundation for everything else.
Okay, step 1, textbooks first. Seriously, don't just jump into practice questions. You gotta build your base by reading the theory from standard, diploma, or DAE books. Step 2, get yourself a dedicated notebook just for formulas. This thing is gonna be your best friend, especially for subjects like mechanics. Third, think visually. For stuff like drawing and construction, if you can draw it from memory, you get it. And finally, number 4, you have to practice with past B11 grade papers. This is non-negotiable. It's the only way to really know what the exam feels like.
All right, you ready for this? We're about to go into a lightning round. I'm talking a super fast overview of 8 key subjects. I'll point out the absolute must-know topics for each one. Let's go.
First up, building materials and construction. For materials, you've got to know your cement types, the water-cement ratio is a classic, and definitely know your brick classes. When it comes to construction, think about how it all fits together. You need to master foundation types, know your brickwork bonds like English and Flemish, and understand exactly what a Bpsc or damp-proof course does. Next, let's talk infrastructure. For highway engineering, I can almost guarantee you'll see a question on super elevation. Also, nail the difference between flexible and rigid pavements and know those basic bitumen tests. For water supply, it's simple. Clean water in, wastewater out. So focus on things like water pH, different filtration methods, and the basics of septic tank design. Okay, on to the management stuff. Estimating and costing, that's all about the money. You need to know the different kinds of estimates, the standard units for measurement, and the basics of rate analysis. Then there's construction management, which is all about the plan. The big key words here are CPM and PERT. You also need to know about site organization and how the whole tendering process works. And rounding out our lightning round, we have building services and drawing. Services are the things that make a building work, right? So ventilation, plumbing systems, fire safety, that's the stuff. And drawing, well, that's the language of civil engineering. You absolutely have to be solid on orthographic projections, how scales and RF work, and the very basics of AutoCAD. Okay, well, let's take a breath. Lightning round is over. Now we're going to change gears, slow things down a bit, and do our first deep dive. We are going to really, truly master the key ideas in surveying. So what is surveying, really? When you boil it all down, it's just the art of figuring out exactly where things are. That's it. Every single civil engineering project starts with these measurements. Now, a huge piece of surveying is something called leveling, and you've really got 2 main ways to do it. First is the height of instrument, or HI method. Think of this as your fast option. Fewer calculations so you can move quicker. Then you have the rise and fall method. This one's slower, but it's got more checks built in, which makes it way more accurate when you need that extra precision. Okay, don't let all the technical terms for leveling freak you out. It's actually super simple. I want you to picture this. You're hanging a picture on a wall. You want it perfectly straight, right? Well, your dumpy level is just a fancy laser level. It shoots out a perfectly flat line. The height of that laser line, that's your height of instrument. And every measurement you take is just asking one simple question. How far is the ground from that laser line? That's all it is. Simple, right? All right, on to our second deep dive. We're tackling the big one, the subject that gives a lot of people trouble. Structural mechanics. But trust me on this, once you get the main ideas, it's like a light bulb switches on and everything just clicks. So what are we even talking about with mechanics? In the simplest terms, it's the science of how stuff bends, stretches, and breaks when you push or pull on it. It's all about figuring out those invisible internal forces, the stress and strain, that are either holding a building up or letting it fall down.
And this right here is the key to understanding the two most important concepts, shear force and bending moment. Forget the textbook definitions for a second. Just grab a wooden ruler. Imagine trying to slice it in half with a pair of scissors. That slicing force, that's shear force. Now imagine taking that same ruler and bending it until it snaps in the middle. That snapping force, that is your bending moment. And those diagrams we have to draw, the SFD and BMD, they're just maps that show you where the slicing and snapping forces are strongest along a beam. That's it.
Okay, so how do we put numbers to this? It all comes down to these three basic ideas. Stress is just how much force is packed into a certain area. Strain is how much something stretches or squishes compared to its original size. And Hooke's law, well, that's the golden rule that ties it all together. It just says that for most materials, stress and strain are proportional. This single relationship is the foundation for pretty much all structural analysis.
Phew, we've covered a ton of ground, haven't we? From that crazy lightning round to our deep dives. So now let's pull it all together and talk about your final blueprint for acing this exam.
Look, if you take only one thing away from this, let it be this. The goal here is not just to memorize a bunch of facts and formulas. It's about understanding the why behind everything. Why does that formula work? Why do we choose one method over another? When you understand the why, you can solve any problem they throw at you. That is the real key to success.
So there you have it. You've got the strategy, you've got the key concepts, the blueprint is laid out right in front of you. The only question left is, are you ready to start building your future?